This is Quick Clip 1.06 Kinetic Energy, and we'll start off with a definition of kinetic energy. It is the energy an object has that is due to its movement. So any object in motion will have kinetic energy. Its formula is going to be Ke equals 1/2 times the mass of the object times the velocity of the object squared. So we square the velocity, then multiply it by the mass, and then multiply it by 1/2. And so we will take this example of a bowling ball striking a pin. Its mass is going to be 5 kilograms, and its velocity is going to be 4 meters per second. And so again, we have the equation Ke equals 1/2 times m times v squared. And that gives us our equation here of 1/2 times the mass, which is 5 kilograms, times the velocity, which is 4 meters per second, squared. And to do the math in your head, you can just square 4 meters per second. That gives us 16. Multiply that by 1/2, and that gives us 8. And then 8 times 5 brings us to 40 joules. So just a little shortcut on how to do a math problem like that. The lesson also talks about the pendulum, and in a couple slides I'll explain why they talk about the pendulum, how that's a really good example of kinetic energy. But first, let's go through the parts of a pendulum. First, we have the pivot, and the pivot is where the pendulum is attached to an unmovable object, right? So that's the attachment point, and that's the pivot point where it's going to swing. Next is the bob, and the bob is the mass at the end of the pendulum. And then the arm is the string or the bar or the chain that attaches the bob to the pivot. All right. Now, when the pendulum is in motion, we have two items to think about. One's the amplitude. Now, the amplitude is not what you might think it is. The amplitude is the angle the pendulum swings from its original position. It's not the height of the pendulum. It is the angle of which the pendulum swings. All right, and you can see that symbolized by the triangle in the diagram. And then there's the period, and the period is the time it takes for the pendulum to swing from one side to the other and then back again. So it starts at one side, swings to the opposite, and then returns to the start. And that would be the time it takes for one period. Okay, so the reason the lesson talks about a pendulum is that it helps illustrate how kinetic energy changes as it swings. So when we look at the pendulum, when it's at its very height, right, there's a little pause. And so when it pauses and reverses direction, it's going to have the least amount of kinetic energy. But then when it is excuse me, at the bottom of the swing, that's when it's going to have the fastest. So fastest at the bottom, right? And it's going to have the greatest kinetic energy. And then at the top, when it's switching directions, that's where it's going to have the least amount of kinetic energy, because in order for it to change directions, it has to go to a zero velocity. And as an example, we have, let's say, we have Taz kicking a soccer ball off a roof. And so the mass of the soccer ball is 0.2 kilograms. The velocity at that moment where the ball is halfway falling down, well, we're going to say that the velocity is 20 meters per second. And that gives us the formula kinetic energy equals 1/2 times the mass 0.2 times 20 meters per second. And then we square that, and that gives us a total of 40 joules. All right, now keep that in mind that our kinetic energy was 40 joules halfway down. All right, next we're going to have him kick the ball, and it's going to come all the way in just before it strikes the ground, we're going to calculate its kinetic energy, right? It hasn't struck the ground yet. It's still moving. So again, the mass is 0.2 kilograms. The velocity now, it has sped up because it accelerated because of the gravity, right? So now it's going 30 meters per second. And our formula is again 0.5 times 0.2 kilograms, but this time it's 30 meters per second. And that brings us to 90 joules. So notice that the kinetic energy is greater when it's going faster at the bottom of the fall, and it was less when the velocity was less halfway through the fall. Much like a pendulum, right? The kinetic energy is going to change depending on the velocity. All right, see you on the next one.